It's, it's really great to be here today among such a brain trust and to hear such inspirational and also very, very important discussions going on today. So my name's Tom Mills, maybe even following on from the name-based discussion we had earlier. Thomas comes from doubting Thomas in the Bible, and I think it's important for us always to be questioning and also being curious, so that's where I come from. Hopefully we'll get into that today. I'm the co-founder of the Carbon Removal India Alliance, which is a group of organizations trying to catalyze a thriving carbon removal sector within India that creates jobs, builds investment, and leads the world in removing carbon in a way that increases climate resilience for those who are most climate vulnerable. And so it's wonderful to hear stories about those who are doing it today. I'm really going to talk about three things today. Firstly, that carbon removal is required in order to meet the Paris targets, 2 degrees, best efforts towards 1.5 degrees. That a portfolio of solutions is going to be required, and that scale up and that speed at which we deploy them is going to be something that has been unseen in many industries. And finally, that India has the potential to be the most land, energy, and resource efficient place in the world to do this, while having the greatest benefit for global society. So what I wanted to start with was by showing you what a ton of carbon dioxide looks like. So carbon dioxide in the atmosphere is around 0.04%, so it's incredibly dilute. And when we start to scale up our emissions, we can see that this has a very large mass and a very large area. This is New York's annual emissions, 92 megatons, 92 million tons of carbon dioxide. In this presentation, we're going to be talking in quite high numbers, billions of tons. And when we're thinking about this is 92 million, just think about what a billion tons looks like and what it's going to take that out of the air. As we talked about earlier, we're talking about concentrations of carbon dioxide in the atmosphere. The blue line here shows this rapid increase from the 1970s, from around 350 parts per million to around 430. We're looking at that going to around 450 over the course of the next 2 decades, up to around 450 parts per million. Each year we add 2.5 parts per million onto that number. It's incredibly scary. We have 2 levers that we can pull. The first lever is around reducing the amount of carbon dioxide we're putting into the atmosphere, and we've been hearing about some incredible solutions that are being developed to do that. Transitioning our energy system, transitioning our devices and transportation over to electricity, and increasing energy efficiency and our ability to manage variability. That will get us almost all of the way there, and we hope it will get us all the way there. However, there will be some emissions that, due to political, social, technological, or economic reasons, won't be abated. And there's this second lever that we need to pull. And this second lever is there, that we need to be able to take those emissions out of the atmosphere that still are there in 2050. So we're going to have 2 trillion tons of carbon dioxide that we need to take out to take us from that 450 to around 350 parts per million that we need. This is a massive, massive challenge. And when we think about where we are today, all scientific consensus shows that we will need to have carbon removal. The Intergovernmental Panel for Climate Change says that by 2050 we will need between around 5 billion tons removed per year to around 10 billion tons per year, depending on the scenario. Today, we have around 2 billion tons of that taken out through these incredible projects that we were talking about earlier: forestry, regenerative farming, and coastal wetlands. The way nature can take carbon dioxide out of the atmosphere. And that really starts to look at one of the key carbon cycles that we have, the fast carbon cycle, where we're looking at a timescale of between days, decades, and maybe up to a century. So when we're thinking about removing carbon dioxide the big thing we're thinking about here is permanence. How long can we store that carbon dioxide so it's not liberated? We have, in addition to this fast carbon cycle, where we have some solutions to manage and look at and solving this, we also have a slow carbon cycle. This is where, over millennia, carbon dioxide has been converted into hydrocarbons, and then we've released those hydrocarbons into the atmosphere. But also, in very slow scale, we can see carbon dioxide be taken out of the atmosphere in terms of converting vegetation into inertinite or biochar, or by the weathering of rocks and silicates, which slowly carbonate and make their way down into the oceans, and then ocean debris filtering down and ending up on the bottom. So there are these, it's worth us thinking about these two carbon cycles when we're thinking about carbon removal. We also have this concept of like-for-like removals. So for this second, for these slower carbon cycle removals, we should be looking at permanent millennia geological timescale removals and solutions for that part of it. So in comparison to where we are today, when we're looking at those permanent solutions, we are nowhere near where we need to be. So we are around 0.05% towards getting to that 10 billion tons of where we need to be today for those permanent solutions. There's only a tiny amount has been delivered today, and it needs to scale up by around 150,000 times. So we're talking about, over the next 2 decades, building 30 companies the size of Royal Dutch Shell. You know, we're talking about scaling at 46% per year on year to get to the scale that we require by 2050. We're also talking about reducing down the costs of doing this by about 15% per doubling of our units, you know, quite similar to where we were with solar PV. However, the good news is we're seeing a massive amount of money coming in to this area. We're seeing big companies, Microsoft, BCG, Airbus, Morgan Stanley, Amazon, starting to directly purchase carbon removal credits, but also governments such as Switzerland acknowledging they will have to start buying carbon removal credits from outside their borders, and the US starting to directly purchase carbon credits onto its balance sheet as well. States of California, states of New York also starting to do this. So when we talk about a portfolio of solutions, we have the ability to speed up natural processes, for example, through accelerating the weathering of rock. We have the ability to take surplus biomass and convert it into, and lock that carbon into those solutions. We have the ability to suck carbon out of the air using big fans and putting it back into the geology. And we have the ability to store that carbon dioxide in products, building materials, and a variety of other aspects. But I really wanted to talk today about 2 areas that India is really leading the way in. The first is around biochar, and it was wonderful to hear so much reference of this today. Biochar is a process of taking biomass, typically surplus biomass, running it through a process of pyrolysis where we're taking oxygen out of a combustion and pressure chamber and resulting in a material that can be used either as an input into different industries, but also as a fertilizer. And this is incredibly interesting within India. And also the second area I want to talk about is enhanced rock weathering. Spreading silicate rocks over land, allowing it to react with water, combining to create carbonates, which then ends up over time in the oceans and is locked forever. And the great news on this is India is the one place in the world that has the optimal conditions for accelerating this weathering. Its climate is hot, it's humid, it has monsoon rains. Nowhere else can do this better than India at scale. It has a ready supply of basalt rock through the Deccan Traps, one of the largest igneous provinces in the world. And it also has large carbon storage capability. India has the biggest concentration of croplands in the world, 165 million hectares, and it has the second largest provision of surplus biomass. Combined with that, the third largest startup ecosystem, 1.5 million engineers coming off their training each year, and the sixth highest number of publications in research, high quality research journals each year. It has this ability to generate the research and development that will be required. Combine all this together, and India has the ability to provide between 10 and 30%, almost a third, of the world's requirement for durable removals technologies. And also, it has this requirement for this to be paid for in the global north, and for those who have historically contributed to emissions to transfer capital into India, which has contributed the least, but while at the same time is the most climate vulnerable. India has the highest social cost of carbon anywhere in the world. For 1 ton of carbon emitted, it will be felt the most in India. My last sort of 2 points is around, while doing this, we can avoid air pollution, we can enhance the soil. Soil quality in India is not robust, it's highly acidic. Crop yield improvement from these technologies are between 16 and 35%. We can improve climate resilience, but also we can reduce that dependence on chemicals and fertilizers within the agricultural system. But we need technology to do this. We need technology to help us to measure, report, and verify the carbon removed. We need technology to build the marketplaces for those inputs that we're talking about, and also to have those outputs distributed. We need technology to create the financial products to allow them to benefit from carbon credits, and also we need to have the benefit from increasing logistics efficiencies to make the maximum carbon benefit. So India has the opportunity to be the place in the world to do this. It's why I, as a Brit, are coming to talk to you today. Thank you very much.
Thank you, Tom.